this video, we're going to start doing some math review, and everything we do here is going to be very important. I'm going to split this up into probably 3 different parts so that each lecture doesn't get too long. And we're going to start at the very basics with things that you really should have a very good grasp on, but we're going to review them anyway because if you don't use this stuff, you get rusty on it. We all do. So let's start with talking about graphing lines, and very quickly let's just review the equation of a line. Usually you're taught in math class that it's y equals mx plus b. Usually in economics, instead of writing mx plus b, where y is whatever's on the y-axis, x is whatever's on the x-axis, m is the slope. Remember, slope is rise over run. The ratio of how much you're going up or down, rise, to how much you're going left and right, run. And then b is the y-intercept. Usually we'll write it with the y-intercept first. Makes it a little easier to graph, in my opinion. And then we'll write the slope times x over on the right-hand side. And many times what we're looking at is graphing things like demand or cost functions, anything like that. We're going to have either price or something in dollars on the y-axis, and we're going to have quantity or some number of things happening on the x-axis. We're going to write, instead of y, we'll write p here, and then we have the y-intercept, 10, and minus 2, the slope, times q. Now this 10 is the y-intercept, and the y-intercept tells us if q is 0, right? If we just plug in 0 here for q, we're going to get 2 times 0. Well, that part goes away. We get that the price is 10 when the quantity is 0. So here's where the quantity is 0 down here. The price is 10. That's where we can start our graphing. And then to get the rest of the points, some people like to fill out a little table of prices and quantities. That's fine. In this class, when you do math, I want you to do things the way that you are most comfortable with. As long as it gives you the right answer, it's fine with me. I'll usually give you a few options and you can pick whatever works for you. But don't worry about pleasing me with how you do your math. Please me by doing it correctly and understanding what you're doing. Say, well, we've got 1 point, we're graphing a line. All we really need is 1 other point. But usually if you're doing this by hand, you want to have more than just 1 other point. So maybe we could say, well, what if quantity was 2 and what if quantity was 5? Just randomly picking a couple of quantities here. Then we could plug in a quantity of 2 for q here and get 10 minus 2 times 2 is 6. And that gives us another point. 2 for quantity, 6 for price. 5, 2 times 5 is 10, 10 minus 10 is 0, so quantity is 5, and price should be 0. And we connect those dots, and we've got a straight line. Now, another way you could do it is to say, well, I know that minus 2 is the slope, and minus 2, slope is rise over run, and if that equals minus 2, that's the same as minus 2 over 1. Putting the 1 on the bottom just helps us see that each time we rise minus 2, that means go down 2, we're going over 1. So down 2 over 1. We're going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and that has to be what this demand function looks like. Tells us that each time we want to sell 1 more unit, we have to lower the price 2. That's what that minus 2 slope means. Down 2 for every 1 we go over 1. Over here, p equals 3q. We don't see a y-intercept sitting there by itself, so we know that must be 0. So the y-intercept is 0. And then the slope is 3. And so we could go up 3 over 1, up 3 over 1, up 3 over 1, and this is what p equals 3q would look like. And that could be a supply curve, perhaps, since it has a positive slope. All right, in this next one, it's written as q equals 2p minus 4. So if you're going to graph a demand curve where price is on the y-axis and quantity is on the x-axis, we want to have this written in the P equals form. And we'll talk a little bit more about the two different ways of writing this in a few minutes here. So I would just take a minute and solve that for P. So let's take a minute and do that. So if you want to solve this for P, we want the P term on the left-hand side. So subtract P from both sides. I have Q minus 2P equals minus 4. We want to subtract Q from both sides. So subtract Q from the left. We have minus Q on the right. And now everything's negative. We want to multiply everything by minus 1. Do the same thing to both sides of an equation. It doesn't change anything. So multiply everything by minus 1, and that makes this a positive 2P equals a positive 4 plus a Q. And then we just want that as P, not 2P. So divide both sides by 2. And that's going to leave us with P equals 4 over 2, 2, plus Q over 2. Which we could also write as 1/2 Q or 0.5 Q. So now this is a little easier to graph. We see it has a positive slope. We see it has a y-intercept of 2 and a slope of 1/2. Again, that slope of 1/2, think about it as 1 over 2, rise over run. So the rise on the top, run on the bottom. That tells us that when we go up 1 rise, we're going to run 2. Up 1 over 2, up 1 over 2. Or we could fill out a little table of values or just plug in a few values for Q right here and see what P's pop out to get a few points to graph. Again, there are a lot of options and there's not one right way, or we might call that a supply curve since it has a positive slope, but it could be something else altogether involving price and quantity. We don't know. Do things in a way that makes you comfortable, that makes you confident that you're doing it correctly. Now here we have some non-integer values. So we have 4.3 for the y-intercept, 2.3 for the slope. Here we're going to have to use our best approximate plotting since we're doing it by hand. So we could plot that 4.3. So when quantity is 0, price is 4.3. It's a little less than 4.5. So I'm putting it a little closer to the 4 than the 5 there. And now we could try to go up 2.3 and over 1. In practice, I think that's a little difficult to do. What I would probably do instead here is go with the table kind of method. Maybe ask, well, what would happen if we plugged in 3? Why 3? Well, why not 3? Plug in 3 for Q there and just see what we get. 2.3 times 3. Grab our calculators, or we could do it in our heads. Looks like it's going to be 6.9. And 6.9 plus 4.3 gives us 11.2. Now in that case, we're kind of off the scale, and we could kind of guess where that 11.2 would be. Or we could back off a little bit and say, okay, well, instead of plugging in 3, let's plug in 2, and that'll give us a lower number for P here. So 2 times 2.3 is 4.6. 4.6 plus 4.3 is going to give us 8.9. Okay, so when quantity equals 2, 8.9 is going to be almost 9 there. And we just do the best we can there, plotting at least 2 points, using a ruler, connecting a straight line. All right, we need to be able to go backwards too. So sometimes we'll be making graphs, but we need to understand what we're making. And other times we'll be looking at a graph and having to really make sure we understand what's going on with this graph and figuring out sometimes what kind of function would make that kind of graph. So here we want to write P equals, find the y-intercept, find the slope. So here's the y-intercept, 7. That's easy enough. And the slope, we just want to pick any 2 points and calculate rise over run. And the easiest 2 points in this case would be these, A and B. And here we see when we go between A and B, we're going down 7 and we're going over 7. So minus 7 over 7, the slope is minus 1. So 7 minus 1Q, but we don't have to write that 1 there. We could just write 7 minus Q instead, right? All right, let's have a look at this one. P equals, or Y equals, it just depends on the scenario, but let's stick with P. We see the y-intercept down here is 0. Okay, so 0 plus positive slope, and pick any 2 points. Okay, let's pick this y-intercept. Let's pick a point over here. And between those 2 points, we're going up 5. We're going over 5. So 1 is the slope. So P equals 0 plus 1Q, or much simpler, P equals Q. It just tells us that whatever value we see on the price axis here is the same as the value on the quantity axis. Sometimes we'll call this a 45-degree line, because since this is a 90-degree angle there, the angle between this line and either the x-axis or the y-axis is half of 90 degrees. All right, let's see here. P equals the y-intercept down here. Looks like it's minus 1. And the slope. Just pick any 2 points, figure out the rise and the run. Okay, I'm just randomly picking a couple of points here. So between those 2 points, we're going up 1, 2, 3, 4, 5, 6. So the rise is 6. The run is 1, 2, 3. So 6 over 3, slope is 2. 6 over 3 plus 2q. And over here, P equals, we see the y-intercept is here at 8, and this negative slope. With a negatively sloped line, it's usually easiest just to pick the 2 points where it intersects the y-axis and the x-axis. And you can very quickly see here we're going down 8, and we're going over 5. So the slope is minus 8 over 5. All right, 8 over 5, Q. Or you could write this a few other ways. You could say, well, 8/5 is 1 3/5. So you could say 8 minus 1 3/5 Q. It's fine with me. A little bit more practical way to write 1 3/5 would be to do it in your calculator, or if you just know that 1/5 is 0.2, 8 minus 1.6, 3/5 is 0.6, 3 divided by 5, Q is probably the most convenient way to write that equation. So on the 4th and 5th pages of this handout, I have practice problems for most of these things. Practice these. I'll post the answers for you, and make sure you do these and check them. If you're really good at this, it shouldn't take you but a couple of minutes to do these practice problems. And if it takes you more than a couple of minutes, you really need to do them anyway. All right? Take advantage of the chance to do this practice and check your answers. I do it all the time. Next thing I want to discuss is the difference between what we call a demand function and an inverse demand function. Demand is when we can plug in a price into a function and it gives us the quantity. All right? So demand is Q equals some function of price. So for example, a linear demand function, when we're really calling it demand, what we want is Q on the left-hand side by itself, and then some function on the right involving price. So this is a demand function, Q equals 20 minus 2P. The inverse demand is what we've been graphing up here, with P on the left. Although here we started with a demand function with Q on the left, and to make it easier to graph, we solved for the inverse demand. So again, we think about demand as being the thing that gives us quantity, because the definition of a demand curve or demand function is for every possible price, what is the quantity demanded? What is the relationship between the price and the quantity demanded? So demand gives us that quantity for all possible prices. The inverse demand is just the inverse. The inverse of a function is when you solve for the other variable, right? If we take this and we solve it for P, we'll get the inverse demand, and that's something that's going to be easier to graph. So just practicing solving functions is always good to get to where you're very good at it. So we're going to do this a few times here. So what I would do, there are a lot of different orders of steps and a lot of different ways you could do this, but what I would do, let's just go over here to the right a little bit. I would add 2P to both sides. So here we're going to have Q plus 2P equals 20. That minus 2P will cancel on the right-hand side there. And then I would subtract Q from both sides. All right, so then we have 20 minus q equals 2p. And then we need to divide everything by 2. So then we'll have p equals 20 divided by 2 is 10 minus q over 2, or 1/2 q, or 0.5 q. All those are perfectly good ways of writing that. And I don't have a preferred method. I want you to use your preferred method when you do these things. All right, so we have p equals 10 minus 1/2 q. Now, something I want you to notice is that when we take the inverse of the function, the slope minus 2 here, the slope on the inverse is actually the inverse of 2, right? Remember, the inverse of a number is 1 over that number. So the inverse of minus 2 is minus 1/2. The slope is the inverse of the slope of the other function. This is a good thing to notice because it's going to be a good way for you to check when you're doing the inverse of a function to see if you've done it right. You want ways to check yourself, and I'm going to give you a lot of ways to try to check your math as we go through this class. All right, here is 2 more examples. So here we have p equals 5 minus 0.5q. First, let's graph it down here. So the y-intercept is 5. The slope is minus 0.5, which is minus 1/2, right? So minus 1/2 means minus 1 is the rise and over 2 is the run. Minus 1 over 2, minus 1 over 2, minus 1 over 2, etc. And then we can connect those dots. And again, that could be a demand curve. Let's solve this for what we'd call the demand function, the q equals version. So what I would do here is add 0.5q to both sides. Again, you can do these in any order. Do whatever you're comfortable with. We would have p plus 0.5q equals 5. And then subtract p from both sides. All right, minus p. And then we need to get rid of that 0.5. So we could divide everything by 0.5. Divide everything by 1/2. But dividing by 1/2 is the same as multiplying by 2. So multiply everything by 2. And we end up with q equals 10 minus 2p. Now I want us to look at these 2 functions here. The demand, q equals 10 minus 2p. And I want us to look at the graph and make sure we understand always, what's the equation saying and how does that relate to what the graph is telling us? It's very important to be able to understand both and how the equations and the graphs work together. Now remember, this 5 here in the inverse demand is the same as this 5 on the graph, the y-intercept. Now this 10 over here is the same as this 10 down here, this x-intercept. The x-intercept tells us that if we plugged in 0 for the price, that the quantity will be 10. And that's the same thing the graph is telling us. If the price equals 0, down here, the quantity is 10. So if we were giving these things away for free, people would want 10 of them. Over here, the 5 is telling us that if we charge $5, people will want to buy no units. So it's important to think about, jump inside the graph, think about what the graph is telling us. So let me just show you what's going on a different way. If we were to flip the quantity axis and put it on the y and put the price axis on the x, then we would get the demand function is what we'd be plotting and visualizing instead of the inverse demand. Let me show you how we can do this visually real quick. So if we take this, suppose this is a piece of paper and we flip it over to where we're looking at the back. So let me just flip this over. All right, so now we're looking at the back of the sheet of paper, but then in order to get the quantity axis up on the top, we need to rotate this figure like this. Now the Q and the numbers are backwards, but we can see that this is the number 10 right here. And the function we have when we put Q on the y-axis is 10 minus 2p. All right, think about that. Take a piece of paper and do this. Flip it over, rotate it, hold it up to the light, and you'll be able to see what we're talking about. So the 5 is the y-intercept. The 10 and the demand function is the x-intercept, or the quantity intercept, and the slopes are inverses of each other. 0.5, 1 over 0.5, all right? All right, now I encourage you to pause the video and try this. If you want to challenge yourself, do this, pause the video, come back. All right, so going through this one very quickly, this is the demand function, Q equals 3 minus a third P. Instead of graphing it directly, let's solve for the inverse, which is easier to graph, and then we'll compare. So solving this, we want to add 1/3 P to both sides. So we have Q plus 1/3 P equals 3. We want to subtract Q from both sides, multiply everything by 3. So we get P equals 9 minus 3Q. Here's 9 minus 3 means down 3 over 1, down 3 over 1, down 3 over 1. All right, so there's our demand function, inverse demand, 9 minus 3Q. And we should see this similar principles that we've been talking about. The 9 is the y-intercept, the 3 is the x-intercept, and the 1/3 is the slope of the demand equation, and the 3 is the slope of the inverse demand, which is what happens if we graph it, okay? So the 3 is telling us each time we want to sell one more unit, we have to lower the price by 3. So down 3, lower the price 3 to sell one more unit. The 1/3 is if we're going the other direction. If we were to start down here, it's telling us that each time we go up 1, we're going over a third. Up 1 over a third, up 1 over a third. Well, I asked a couple of problems in this video. Total revenue is price times quantity, right? It's just how many are you selling? That's the quantity times how much are you selling them for. Total revenue, how much money do you have after you're done selling these things? How much money's coming in total? I say for each of the functions that we're looking up here in these two graphs, let's find an equation for total revenue as a function of quantity. I want you to think about what we're saying here. We have total revenue equals P times Q. Now, just like we have two different ways of writing a demand function, the demand, Q equals, or the inverse demand, P equals, there are a couple of different ways that we could write a total revenue function. One, total revenue as a function of Q, which is what we want, or total revenue as a function of P. They're both useful. Neither one is wrong, neither one is right. They're both useful. It just depends on what are you going to use it for. Would you rather have a function where you can plug in the quantity that you have on hand and that'll tell you total revenue? Or would you rather have a function that tells you for any price you decide to charge, what will my total revenue be? Well, they're both useful. And let me show you how you could get either one of them. For this graph on the left-hand side, let's write down the two equations we have for the demand. So we have P equals 5 minus 0.5Q, or we have Q equals 10 minus 2P. Let's see what would happen if we take this P and we're saying, what this equation is saying is that this right-hand side, 5 minus 0.5Q, is P. So what we can do with that is we can take that part right there, we could plug it in right here for P, and see what happens. So now we're going to end up with total revenue equals P is 5 minus 0.5Q times Q. Okay, times Q. What does that give us? Multiply through with a Q right here. So 5Q minus, we have minus 0.5Q times Q minus 0.5Q squared. And that equals total revenue. Well, hey, look, there's a function of Q that tells us total revenue. Well, you're probably a bit uneasy with this, right? This is weird what we're doing. Let's double check it. Let's just pick a couple of points over here on this demand curve and let's calculate the total revenue and make sure this function is doing what we think it should do. All right, so let's pick a point here. And at this point, the price is $4 and the quantity is 2. First, let's look at the graph and see what we should get for total revenue. $4 times 2. $4 times 2 equals $8 in total revenue. So if we take that 2 units and we plug it in over here, we better get $8. So let's see. 5Q, 5 times 2 is 10, minus 0.5 times 2 squared. All right, 2 squared is 4, 0.5 times 4 is 2. We get 10 minus 2 equals $8. Math works, guys. And that's one of the things we're going to see in this class, is we're going to be using some math in some slightly different ways than you might be used to, applying math to be a powerful tool for us. And it's going to work. And if you check it and it doesn't work, we've goofed up somewhere. So we have here total revenue as a function of Q, where we can plug in any quantity and it pops out the total revenue. Now let's just see what would happen if we did this the other way. What if instead we took this Q and we plugged that in right there for Q in this total revenue function? Let's see what would happen. So here we have total revenue equals price times, and we're saying, well, we know Q is the same thing as 10 minus 2P. All right, 10 minus 2P. And so that equals 10P minus 2 times P, or 2P squared. That's also total revenue. So this would give us a little function where we can plug in a price, and it'll tell us the total revenue we'll get for that price. Let's check and make sure this works. So that same point, we were looking at $4 and a quantity of 2. So if we charge $4, we'd better get a total revenue of $8. Well, let's make sure. Equals 10 times 4 is 40, minus 2 times 4 squared. 4 squared is 16, and 2 times 16 is 32, $8. It works. Kind of cool. We can do this for the scenario on the right too. We know now that if we want an equation that gives us total revenue as a function of Q, what we want to do is plug in this right-hand side here that has the Q in it into the total revenue function. We need to be keeping the Q if we want a function of Q. So for this one, should be total revenue equals price times, we're going to want this part here, 9 minus 3Q. So we want 9 minus 3Q times Q. So that's 9Q. And then what do we get there? Minus 3Q times Q minus 3Q squared. And that's the function we're looking for. And we can pick a couple of points and check this. Let's pick, here's an interesting one. Let's pick this point right down here. What would the total revenue be if Q is 3? Well, if Q equals 3, this is saying that the price has got to be 0, right? So total revenue has to be 3 times 0, or 0. So this function right here, if we plug in a Q of 3, has got to give us a total revenue of 0. Let's check. 9 times 3, 27, minus 3 times 3 squared. 3 squared is 9, times 3 is 27. So our total revenue is going to be $0 if we want to sell 3 units, because we're going to have to give them away for free, right? So the last question on this page says, find total revenue when 2 units are sold. Now we've practiced with doing that a little bit, right? But the last thing I want to mention here is a graphical way to think about total revenue. Total revenue you can think about as the area of a rectangle. And we were doing this just a second ago. Look over at the graph on the left. So here, if you look at 2 units, that green rectangle tells us the total revenue when we charge $4 and we sell 2 units. You can think about this a couple of different ways. Why is it that it's a rectangle? Well, first, total revenue is price times quantity. And the area of a rectangle is base times height, or length times width. And that's going to be 2 times 4, quantity times price, or price times quantity. Another way to think about this is what we're seeing here on the graph is I'm selling 2 units for $4 each. And so here's $1, $2, $3, $4 I'm getting for selling the first unit, and $5, $6, $7, $8, another $4 I'm getting for selling the second unit, and the total number of dollar bills You can think about each of these little boxes as each dollar as it comes in for each unit. There's going to be $8. Just count up the little $1 boxes there. So if you're pretty comfortable with everything we just did, go and practice these practice problems over here and make sure that you understand it, okay? Down to this part. And in the next video, we will start working with exponents and solving exponent equations and doing some work on our calculator with exponents. I'll see you then. Let me know if you have any questions.